Hybrid electric vehicle technologies. In this, we'll discuss micro hybrids, mild hybrids, full hybrids, parallel hybrid, series hybrid, series parallel hybrid, and plug-in hybrid electric vehicles. Micro hybrids. The typical electrical power rating of micro hybrid is between 3 to 5 kilowatt. Micro hybrids refer to hybrid electric vehicles with the start-stop or idle stop systems, which automatically shut down the engines when vehicles are coasting, braking, or stopped accordingly to certain road conditions, and restart the engine when speed is regained. Some micro hybrids are capable of certain levels of regenerative braking also. These are simplest hybrids among the various hybrid configurations. They can provide up to 10% of fuel economy, especially in urban driving situations with frequent stop and go. Microhybrids incorporate only small portion of the electric system. Normally, they have a small motor, relatively simple structural design, and cheaper re-engineering cost, while significantly increasing fuel economy and cutting air emissions. Many auto manufacturers applied this technology during the initial transit from conventional petroleum-powered vehicle to hybrid electric vehicles. For example, BMW's microhybrids incorporate efficient dynamics technologies, which aimed at reducing fuel consumption and air emissions. Both start and stop and regenerative braking functions are available in BMW's microhybrid. Volkswagen also equipped its microhybrid fleet with similar features under the name of Blue Moon Technologies. Fiat introduced the PUR02 in the range of its microhybrid models, and Mercedes developed microhybrid drive MHD on its smart hybrid, which is reported to increase fuel economy about 8%. Mild hybrids. Mild hybrids have higher level of electric power rating, typically 7 to 15 kilowatt for a sedan car. Propulsion systems in mild hybrids normally consist of electrical motor generators between the engine crankshaft and the transmission input shafts. The added motor generators provide the vehicle with the start-off function, regenerative braking function, and additional electric power to drive the accessories. Some of the mild hybrids also provide modest level of power assistance to the engine. Mild hybrids are relatively cost effective because they require minimal vehicle platform reconstructions and typically maintain the fundamental manufacturing process. The electric machines can also function to start engine and charge the battery, which is one of the function of the mild hybrids. Full hybrids. Full hybrids have the highest electric portion compared with micro hybrids and mild hybrids. The power rating of full hybrid is 30 kilowatt or higher. Full hybrids are defined as IC engine centric vehicles that can run on either engine only mode, battery only mode, or combine, that is combination of the two. Full hybrids can also operate on an electric range where only electric motors are used to propel the vehicle and supply all the internal power loads. Full hybrid vehicles normally have relatively short all electric range with limited power output, so they can have a short electric range. Typically, full hybrids can achieve more than 40% of the fuel economy in city drives and have more electric power assistance to increase driving performance. Full hybrids employ largest electric portions in the hybrid electric powertrain. Full hybrids have relatively more complicated configurations. Most full hybrids integrate the electric path with the mechanical power path by means of planetary gears. Power split devices serve to divide the power from the onboard power plants, that is the engine and batteries, and redistribute the power flow between the electric path and the mechanical path to achieve optimal fuel efficiency and driving performance. Power split devices and other added mechanical components all add to the complexity of the full hybrid systems. Full hybrids have highest acceptance compared with the other two types, as full hybrids fulfill the demanded purpose of reducing fuel consumption and air emissions. This is the comparison of three categories of hybrid electric vehicles and their features. The main three types, that is the micro hybrids, mild hybrids, and full hybrids, are compared here. So to see the micro hybrids electric rating is in the range of 3 to 5 kilowatt, mild hybrids 7 to 15 kilowatt, and full hybrids they have range above 30 kilowatt. If we compare the fuel saving, micro hybrids give 10% of fuel saving, mild hybrids double of it 20%, and further full hybrids double of the mild, that is a 40% fuel saving. If you compare the cost, micro has the low cost, mild hybrids has the moderate cost, rather full hybrids have the high cost because of the battery and other complicated structure. Added features for this, micro hybrids have the start and stop feature, moderate regenerative braking feature, and accessories powering. The examples of micro hybrids are Mercedes Smart, BMW Efficient Dynamics, Volkswagen Blue Motion. Mild hybrids added features are the smart start and stop, regenerative braking, accessories powering, moderate electric assistance. And the examples are Honda Insight, Chevrolet Silverado Hybrid, Mercedes S-Class Hybrid, BMW 7 Series Hybrid. The special features or added features for full hybrids are they have start and stop facility, regenerative braking facility, accessories powering, electric assistance is provided, electric only drive is possible. The examples are Toyota Prius, Ford Escape Hybrid, Chevrolet Tahoe Hybrid, BMW X6 Active Hybrid. Classification of vehicles based on their powertrain system. 5 different types of hybrid electric vehicles are available. Just we have seen mild hybrid, then parallel hybrid, plug-in hybrid, series hybrid, and series parallel, that is a power split hybrid electric vehicles. Here, the figure shows the different vehicular architecture and their electric and conventional propulsion systems. You can see the conventional vehicle, they have the 100% IC engine contribution. As we move from mild hybrid to the electric vehicle, this IC engine contribution go on reducing, rather the electric propulsion go on increasing. There is zero electric propulsion in the conventional vehicle, that is IC engine vehicle, but it is almost 100% in the electric. It is 100% in the electric vehicle. In between that, it goes on increasing the electric propulsion and reducing the IC engine contribution from mild hybrid, then parallel hybrid, then series parallel hybrid, then series hybrid, plug-in hybrid will have the highest electric propulsion, and then electric vehicle will have the 100% electric propulsion. We'll further discuss in details the mild hybrid electric vehicles. Figure shows the mild hybrid electric vehicle. B is for the battery system, IC is for internal combustion engine, M for electric machines, and T indicate the transmission system into this block diagram. Mild hybrid electric vehicle incorporates a smaller electric propulsion system. Generally, it is integrated in the IC engine. The flywheel system of IC engine is designed as an electric machine. Therefore, the IC engine can be started by electric propulsion, and the electric machine can also power assist the IC engine when the power demand increases. Also, it can recover a certain amount of kinetic energy during the braking phase of the vehicle. So here the figure shows a mild hybrid electric vehicle where a small motor is assisting the IC engine and the source is the battery and power is transmitted by the IC engine and it is supported by this motor. Parallel hybrid electric vehicle. Significant amount of the propulsive power in parallel hybrid electric vehicle is supplied by the electric machine. The parallel hybrid has two independent power flow paths, such as electrical path and mechanical path. So here you can see this is the mechanical path driven by the IC engine drive, and here is the electrical path driven by the motor sourced by the battery to the transmission. So depending upon the propulsive power requirement, the vehicle will run electric only, mechanical only, or combinations of the both. So it can work in mechanical only and not supplying the torque by motor, or it can work electric only, then IC engine can remain into the off condition, or both can supply torque at a time. So as seen, there are four different operating modes in parallel hybrid electric vehicle. The first is IC engine supplies the propulsive torque for power demand. And second, electric machine is only the propulsive medium. Third, IC engine and electric machine supply the propulsive torque demand. Fourth, regenerative braking mode of the electric vehicle, of the hybrid electric vehicle. We can see this mode in a diagrammatic way. The first is the IC engine supplies the propulsive torque demand. So you can see the mechanical system, that is the fuel is given to the IC engine. IC engine will give the transmission power to the wheel axis. The second mode is electric mode, where electric machine is the only propulsive medium. So you can see IC engine is not functioning, but electric motor is providing the required driving torque using the battery power. The third mode is the IC engine and electric machine supply the propulsive torque power demand in a combination, in a combined way. So here you can see it is working. Also, battery is supplying to the motor and it is also working. The another mode is regenerative braking mode of the vehicle, where when there is a downgrade, no input is required from the IC engine or motor, but in turn, the kinetic energy of the motor will be used to drive the generator, which will now work as a generator, and it will give supply to the battery to charge. And some of the energy is recovered during this braking condition. Another type is the series hybrid electric vehicle. Here, the series hybrid electric vehicles are powered by electric machines. Series hybrid vehicle incorporate two electric machines and one IC engine in the propulsion system. One electric machine is directly attached with the IC engine, that is shown here, is, is attached to the IC engine. And most of the time it functions as electric generator. So this mostly function as electric generator during the starting of IC engine. It acts as a electric motor in during the starting. Another electric machine, that is this N, is integrated with the transmission system. You can see it is connected to the transmission, but this is not connected to the transmission, but it is connected to the IC engine. So another machine is integrated with the transmission system to deliver the propulsive power requirement of the vehicle. Since series hybrid electric vehicle incorporate a bigger electric machine in the propulsion system, their energy recovery capability is significantly higher than other types of hybrid electric vehicle. So electric machine is sufficient rating and they can have the higher energy recovery or regeneration capacity, regenerative braking capacity. Now, 6 different operating modes can be observed in series hybrid electric vehicle. The first mode is electric machine only operates as a propulsive medium, that is electric mode. IC engine supplying the propulsive torque power demand of the vehicle, that is the mechanical mode only. The third is IC engine and electric machines supply the propulsive torque, that is electric and mechanical mode combined. Fourth is the regenerative braking mode of the vehicle where regenerative or recovery of the electrical energy is taken by the regenerative braking method. The fifth is IC engine supplies the propulsive torque power demand of the vehicle. Also, the excess power of the IC engine is converted into electrical energy and stored to the battery. So, in addition to providing the torque, IC engine also supplies input to the battery, which is the fifth mode. And the sixth mode, IC engine charges the battery system only. And also, battery can receive power from regenerative braking. These modes are shown into this figure, where B is the battery system, IC is the internal combustion engine block, M indicates the electric machine, T indicates the transmission system. The first diagram indicates the electric machine is only propulsive medium. So you can see the battery will supply to this motor and this motor will drive the vehicle. The second mode is IC engine is supplying the propulsive torque power demand. So in this mode, second mode, we can see IC engine is supplying the propulsive torque. So this will act as a generator now. So IC engine, which is driving the generator, and then it will give supply to this motor, and then it will provide the transmission torque. The third mode is here, the IC engine and electric machines are supplying the propulsive torque or power demand simultaneously. So you can see here the IC engine is also supplying and the electric motor is also working here. So both will provide the torque to this. The fourth mode is regenerative braking mode of the vehicle. In the regenerative braking, you can see the energy is recovered when the vehicle is moving downgrade and energy will be stored into this battery. The fifth mode is the IC engine supplies the propulsive torque power demand of the vehicle. So you can see IC engine will supply the propulsive torque demand of the vehicle. And the last mode is IC engine charges the battery system. Also, battery can receive power from the regenerative braking. So IC engine is charging in this way. Also, it can have the regenerative braking. The next is series parallel hybrid electric vehicle, also called as a power split hybrid electric vehicle. It incorporates two electric machines and an internal combustion engine for the propulsion purpose. Contrary to the series hybrid electric vehicle, the power split or series parallel hybrid electric vehicle use low power electric machines and both of them can act as motor and generator. Here, two electric machines and an IC engine are connected to the drive axle via planetary gear system. So we can see the IC engine is also connected to the transmission system. The motor 1 is connected to the transmission system and motor 2 is also connected to the transmission system as compared to the earlier system. These three are connected here, but as compared to the earlier system, we can see only this motor is connected to the transmission and these two are not connected to the transmission in series hybrid. That is the difference here. So you can see connected via this planetary gear system is there. The ingenious arrangement of this gear system allows the propulsion system to have much more flexibility while achieving different propulsive requirement. It also achieves many different power flow patterns by choosing different combinations of power sources. Here we can see the different operating modes. The first is IC engine is only propulsive medium. So you can see the first, the IC engine is providing this input. Here part of the power produced by the IC engine is converted by a motor to the traction wheels. So here we can see this. The second is IC engine electric batteries are supplying the propulsive torque or power demand. So IC engine and the battery both are supplying. The third one is IC engine is supplying the propulsive torque power demand while the battery is charging. So you can see it's supplying the propulsive torque and battery is also charging here. The fourth mode is batteries are supplying the propulsive demand. Only batteries are providing the propulsive demand. The next fifth mode is IC engine charges the battery while vehicle is standstill. So it is just IC engine is driving this and it is charging the battery. The last mode is regenerative braking of the vehicle. Here we can see the regenerative braking is used. The next type is plug-in hybrid electric vehicles. The plug-in hybrid electric vehicles are generally either parallel hybrid electric vehicle or series parallel hybrid electric vehicle. A typical parallel hybrid electric vehicle incorporates a smaller electric propulsion system and a bigger IC engine. A plug-in hybrid electric vehicle incorporates bigger electric propulsion system and a smaller IC engine based on the propulsion system. Also, the plug-in hybrid electric vehicle incorporates an external charging system. It can be used to charge the battery from the grid. So this is the major difference in the conventional hybrid electric vehicle, that is a, for example, a parallel hybrid electric vehicle and the plug-in hybrid vehicle, where the IC engine is having the larger size and the battery is smaller. But in plug-in electric vehicle, the battery is of sufficient size and sufficient size motor is there. And there is a charging facility is there which will charge from the grid. Also, it can supply back the energy to the grid in case the battery is fully charged and it can give back supply to the grid. Plug-in hybrids have higher regenerative braking capability as compared to traditional hybrid electric vehicles. Plug-in hybrid electric vehicles are highly desirable for city driving cycles.